We are going through exercise 6i, and in this video we'll be answering question 3a, which is asking us to solve each of the following equations for x, and for a we've been given x to the power of 4 minus 27x equals 0. I'm going to be showing you two ways, option 1 and option 2, for answering this. Both of them are valid. I just want to show you that there's multiple ways to approach a question like this. The first step of both options is going to be the same, and that is take out any common factors. And obviously we can take x out of this. We can take x out, which is going to leave me with x to the power of 3 minus 27 equals 0. Once I'm here, I can now use my null factor theorem, which tells me that either of these is going to be equal to 0. So it's going to be x is equal to 0, or it's going to be this is equal to 0. X cubed minus 27 equals 0. Obviously, this is as good as it gets. It's x is equal to 0. So let's just highlight that. But now I need to get this in that form. I need x by itself. To do that, we're going to just have to go through a few steps. First of which is plus 27 to both sides. So let's do that. Then I'm going to get x cubed equals 27. The next thing that I want is to just get x by itself. So I'm going to have to cube root this to get rid of that cube, and we have to cube root that. When I do this, let's scroll down, what am I going to get? I'm going to obviously just get x on this side, and now on this side I'm going to get 3, because 3 times 3 times 3 is 27. Very importantly, it is not plus or minus 3, it is just 3. When you're cube rooting something, it is just that number. Only when you're rooting something to an even power, so if this was a square root or a fourth root, then it would be plus or minus. Very important there. So we're done. There are our answers. X is equal to 0 and x is equal to 3. And you're probably thinking to yourself, you know, that was pretty easy. Why would I show you a different way? But I'm just going to show you a different way just in case you're curious. So the other way that we're going to do is just really more factorizing. So our first step is going to be the same. It's going to be taking out that x as a common factor, x cubed minus 27 equals 0. The next thing that we're going to do is we're going to factorize this right here. And we know how to do this. This is a difference of cubes. So remember, when we were factorizing this, the very first step we did was say, all right, this is x cubed, obviously, and this is going to be 3 cubed. Having written it like that, we can then factorize it. So we still have this x out the front. It's going to be x minus 3. Then I'm going to square the first term, so x squared. Then I'm going to multiply these together, and it's going to be a plus 3x. And then I'm going to square the last term, plus 9. So hopefully that made sense. We've done that a lot in the past. I'm not going to go through it that much. Once we're here, now we can use our null factor theorem again and just set everything equal to 0. So it's going to be x is equal to 0, because I haven't, so x is going to be equal to 0. Then it's going to be x is equal to 3. So I'm setting each of these equal to 0. And then this right here, if you were to think about the discriminant of this, is going to be less than 0. So it's not going to exist. You can't factorize this anymore. So there are your two answers. I know that many of you are just going to say this is way easier, and probably so. But it's also important that you remember how to factorize these difference of cubes, or if this was a sum of cubes, you also should know how to factorize that, and the only difference is the signs. Hopefully that all made sense, and I'll see you in the next video.